0.7. Okay? In example 4, are you more likely to get 10 points or 5 points? Let's go back up to the dartboard. All right, I've already erased it. I'm not going to go by memory again. So now, which area is larger? The pink area or the green area? Well, we had just calculated the pink area. Let me be mindful of what that was. The pink was 28.3 square inches. Okay? So now if we want to calculate the area of just the green, we need to calculate the area of that whole circle and then remove the pink to see what the green is. So the radius going through the green is 3 plus 3, which is 6. That radius is 6. So I'm going to calculate the area of that middle-sized circle. So that's 36 times pi, and that is 113. And then I subtract out the area of the pink one, which we already know is 28.3. We'll just call it 28 because don't need to be that precise. So 113 minus 28, and I get 85. So the area of the green zone is 85 square inches. The area of the pink zone is 28 square inches, so clearly we're more likely to hit a green than we are a pink. And I know you're probably looking at that going, duh, I could have told you that just by looking at it, and that's true, but many times it is not that obvious, and so you need to do calculations. The last thing says in example 4, are you more likely to score points or get 0 points? Okay, so we go back to the dartboard. This one is the easier of the two to calculate. So all the yellow, the green, and the pink are all point scoring places. The blue is where you get 0 points. We'd already calculated that blue when we did the example. It was 70. I'm using the wrong thing. Try that again. Right, that's the area of the blue, was 70 square inches. So now I want to know what the area of the whole circle, all of it is. Okay, well, the radius is 369, so it's 81 times pi, and that's 254. So clearly you're more likely to score points than not. Okay, almost 4 times as likely. All right, let's go to our last section. Experimental probabilities. An experimental probability is based on repeated trials of a probability experiment. The number of trials is the number of times the probability experiment is performed. Each trial in which a favorable outcome occurs is called a success. The experimental probability can be found using this: the number of successes divided by the number of trials. So what this means is this: the difference between the theoretical and the experimental is that theoretical is what you would predict to be the case. The experimental is what actually happens. So let's say, for instance, Ollie, I'm going to flip one coin. What is my predicted theoretical probability of getting a heads when I flip that?
50.
50%, right? 50-50. However, let's say I flip a coin 20 times and I get 13 heads. Well, 13 over 20, is that more or less than 50%? More. So, but my experimental probability is 13 out of 20 versus 50%. I would predict if I flipped a coin 20 times, I should get 10. I actually got 13. So my experimental probability is different than what my theoretical probability would be. So here's an example. Each section of the spinner shown has the same area. This looks kind of like that game Simon. The spinner was spun 20 times. The table shows the results. For which color is the experimental probability of stopping on the color the same as the theoretical probability? So Holly, I'm going to ask you this question. What would we predict if you were spinning the spinner 20 times? How many times should you get blue?
5.
5, right? Because it's divided into 4. 20 divided by 4 is 5. So your theoretical probability is 5 out of 20, 1/4. Well, let's look over here at the results. Here's what actually happened. When we spun it 20 times, we got red 5 times, green 9 times, blue 3 times, and yellow 3 times. This is how life works. Theoretical probabilities do not predict the exact outcomes of things. They just help you understand where you should see things to trend. Which of those is the one that where the experimental and the theoretical matched up together?
Red.
Red. We predicted it would be 5. and red indeed was 5. It's the only one that came out that way. So we already discussed the solution. What they showed you here is the theoretical probability of each one is 1/4. Here's what the actual experimental probabilities came out to be. Red was 5 out of 20 or 1/4. Blue was 3 out of 20. Green was 9 out of 20, and yellow was 3 out of 20. Okay? And there you have it, solving a real-life problem. I believe this is the last thing in this section. In the United States, a survey of 2,184 adults age 18 and over found that 1,328 of them have at least one pet. If it's the Johnson household, that pet has a chance of living or not living. You just never know how that could happen, right? The types of pets these adults have are shown in the figure. What is the probability that a pet-owning adult chosen at random has a dog? So, we look here, the total number of trials, the number of trials is the number of pet-owning adults, 1,328. What is the probability that a pet-owning adult chosen at random has a dog? Well, of those 1,328, how many had a dog?
916.
916 had a dog. So if you're choosing just the pet-owning adults of 1,328, the probability of them having a dog would be 916 over 1,328, which they reduced down about 69%. And so, just so you can see what this represents, how you interpret that to mean is roughly, if this, remember this is only 2,000 adults in the United States, but if this is a rough, fair sampling of the United States, then amongst people who own a pet, 69, almost 70% of people own a dog. Okay? All right. Monitoring progress, and indeed this is the last thing. In example 5, for which color is the experimental probability of stopping on the color greater than the theoretical probability? And in example 6, what is the probability that a pet-owning adult chosen at random owns fish? Okay, so we're going to pause here for just a moment and let you guys answer these questions. And we're back. All right, so again, number 10, it said go back to example 5. For which color was the experimental probability greater than the theoretical probability? Recalling that our theoretical probability would be 5 times out of 20. When we look over our results, though, we see that one of those, and only one, was greater, and that was the green block. Okay, the green block was 9 when we predicted 5. That's all you do there. And then the other one asked, what is the probability of these pet-owning adults that they chose a fish, that they had a fish as a pet? As you can clearly see here, 146 of them out of 1,328 pet-owning adults. You punch that into your calculator really quick, you get 146 divided by 1,328, and that's roughly 11%. 11% of pet-owning adults own a fish. Okay? And that is the introduction of probability. Again, reread the chapter, listen to this again if you need to. The math is the easy part, the concepts are what you need to understand. And you have a homework assignment to be working on and complete now. Thank you. And the probability of me stopping is 100%. Deuces.